So I'm doing question 8.4.52. It's just solve that integral right there. It's about trig substitution. First step, you set up the triangle right there. Since Pythagorean theorem, square root of a squared plus b squared equals c. So it's rearranging that equation. You get the hypotenuse to be x, then one of the legs to be 3. So this is a secant question, so it's x equals 3 secant theta. Dx of that would be 3 secant theta tangent theta d theta. Solving for the square root of x squared minus 9 would be 3 tangent theta, because it's just plug and chug and then solving out through identities. So because I'm going to do a trig substitution, I just went ahead and changed the limits of the integrand. So when x equals 3, theta equals 0. When x equals 6, theta equals pi over 3. So I did the plug-in. So it's the integral of 0 from 0 to pi over 3 of 3 tangent theta times 3 secant theta tangent theta d theta over 9 secant square theta. So that simplifies to be the whatever 2 tangent square theta over secant theta d theta. So I did all of this. This is all useless. When I realized I was doing this wrong, just go to the next line. You can just, using a trig identity, you can just say that tangent squared theta equals secant squared theta minus 1 over secant theta d theta. That, you can separate that into two different fractions because of basic addition of fraction rules or subtraction of fraction rules. That yields you this and this with the same limits, boundaries. Then you get the integral from 0 to pi over 3 of secant theta d theta minus the integral of 0 to pi over 3 of 1 over secant theta, which is cosine theta of d theta, which then yields you this, which is ln of the absolute value of secant theta minus tangent theta evaluated at 0 to negative 2 pi over 3 minus sine pi evaluated at 0 to pi over 3. When you solve that all out, you get ln of the absolute value of 2 minus the square root of 3 minus the square root of 3 over 2.